steps. So the first thing that we have to kind of talk about is the sampling distribution. It's still checking the same three conditions. Is it random? Is it independent? Is it normal? All of that is exactly the same. Now, the one thing I will kind of point out is it's always going to be a difference between two populations. So this is always going to be subtraction. Anytime you are doing a hypothesis test or a confidence interval, it's always subtraction. So when we go in and we identify our point estimate or our center of our distribution, typically it's always going to be a subtraction. Now, one thing I will also say when you're doing standard deviation, which we've talked about before, is that we have a combined, if we're combining populations together, you are never going to decrease your variability, which is why when we do standard deviation, we always end up adding. Now, it's always going to be approximately normal. We're always going to still check large counts. It has to be randomly selected, and we do have to do 10% condition. The only exception to the 10% condition is if you are doing an experiment. If you're doing an experiment, you can go in and say that they are independent. So if I'm sampling people and trying to test a drug to see if it helps with migraines, I can go in and say each subject that is a part of this experiment is independent. If you are doing sampling, where you're going in and asking people questions via observational study, the expectation is that you check 10%. So all three conditions are exactly the same. You're still doing the same communicate, conditions, calculate, conclude. Everything is the same except for our formula. So when we go in and we are trying to do a two-sample, and I'm going to name this two-sample Z interval for a difference in proportions, and I'll show you how you can kind of shorthand that when we get to an actual problem in just a second. Whenever you're trying to calculate the interval, you do have to go in and first remember that for a confidence interval, it's taking a point estimate plus minus a margin of error. The margin of error is made up of two things. It's made up of your critical value and your standard error. So in the case for a difference in proportions, we are going to have P1 hat minus P2 hat plus minus critical value for any Z interval is going to always be a Z star. And then the standard error is P1 hat 1 minus P1 hat over N1 plus P2 hat 1 minus P2 hat over N2. Now, I don't want you to stress out about the formulas because most of the time you are probably going to do this in your calculator, which is fine. With the formula, they are moving more towards asking multiple choice questions about which of these would correctly calculate the interval, things like that. And so it's mostly just knowing where the numbers go in terms of what formulas they give you. And all of the pieces are on the formula chart, which I'll put up on the board at the very end. You just kind of have to know when to use what. Yes, Precious?
Is it the same thing that we do with the...
It's basically the same thing as the sampling distribution. So we will still get the interval from the calculator as well, but this is just if they ask you questions about the formula itself. Now, one thing I will say, there are some common Z values that are really good to know. For 90%, we said 1.6449. For 95%, we said Z star was 1.96. And for 99%, Z star is 2.5758. And it's optional. You don't have to memorize these. You can technically find all of the Z stars that you need within inverse norm, but these are the 3 most common ones. I would say if there's any one that I would take the time to memorize and know, it's probably going to be the 95%, because that is the most common confidence level that you'll see on any questions that you get. So these are the 3 most common ones. It's good to know, but sometimes they'll ask like 80%. I don't know the 80% one, so I usually just use inverse norm to find that one. The only additional thing that I'll kind of mention is, like what we did with one sample, you don't have to calculate standard deviation and mean and all of that separately. I literally, for my calculate part, am only going to do the formula. So with the conclusion that we write, it's literally the same sentence. We are blank % confident the interval from blank to blank captures whatever you're talking about in the question. So truthfully, the only thing that's going to change is the calculation for the interval, and with the conditions, we just have to make sure we're checking them for both populations. So let's go ahead and jump into an example. I went ahead and I kind of divided my page into 4 sections. So I did a cross right down the middle. Top left, top right, bottom left, bottom right. This is mostly for my spatial visual learners, where if you're like, I know conditions go in the top right corner, it kind of helps you remember that you actually have to check conditions.
You said 4 space?
I did 4. So I did 1 line down the middle, 1 line across. Now, that's just basically taking our vertical blocks and putting them into a 4 square. Completely optional. Again, remember, as long as it's on your paper, they don't necessarily care what order or how you write things down. They just want it on your paper. So for example 1, we have a recent survey wanted to compare the proportion of teens and adults who use social media. The first poll asked a random sample of 300 teens, and a second random sample asked 400 adults. So immediately from the question itself, I kind of already know I'm dealing with 2 samples. In these 2 samples, 92% of teens used a social networking site, and 75% of adults did. With the how do I know what I'm doing, I am constructing and interpreting a 95% confidence interval. So they will give you, for at least confidence interval, a pretty straightforward direction. They will most of the time say the word confidence interval within the question. So that is how you know you should have a range of values that work for this particular setting. I also like to kind of come in and identify what the context is, just to kind of know what has to get written in my conclusion. So I need to have some type of context when it comes to going in and writing out my final answer. Now, just as a little help, because on the test, it will not say construct a 2 sample Z interval for whatever. You have to decide by reading the question what test you should do. So the first thing I like to do is identify how many samples I have. So I have 2 samples. And then I kind of go in and figure out what type of question did they ask. They asked them if they use social networking or not. So that is a categorical question. Anytime you have a categorical question, that is going to be a proportion, which means we need to be using Z's. So Z stars, Z scores, anything Z related is tied directly to proportions. And then the last kind of deciding thing you have to do is this a confidence interval or is this a significance test? And because they want a 95% confidence interval, that means I'm doing a confidence interval. So this is kind of like how I determine what test to do. Is it 1 sample? Is it 2 sample? Is it categorical? Is it quantitative? Is it proportions? Is it means? And those tie directly to categorical and quantitative. And then is it a confidence interval? Is it a hypothesis test? So we kind of have our chain of decision making. Now, both options start the same way. you start off by defining your parameters. So I went ahead and I defined my parameter. I only wrote ahead of time because my space was limited and I started like running out of space in my first couple of times of teaching this. So I had to like pre-plan where everything was gonna go. I have P1 is equal to proportion of teens who use social media, and I have P2 is equal to the proportion of adults who use social media. You always have to define your parameters. You don't have to use 1 and 2. You can, I think in one of my classes, I used T and A. So I did PT for teens, PA for adults. It's completely up to you. I just switched to 1 and 2 because it was easier to kind of work with when I was writing them out. So I have my 2 parameters defined. The only additional thing that kind of has to go in this box, and it's not an absolute requirement, at least not on the AP exam, so I don't require it on my tests. I do think it's helpful to identify, because you're not always writing what I just did at the top. It's helpful to identify kind of what are you looking for. So we're looking for a 95% confidence interval, and that gives me a Z-star of 1.96 every single time. So once I have my parameters and my confidence level, I can then go on and check my condition. So there's 3 things that we have to check. 2 of them, pretty standard. You're probably used to doing them, random and independent. The one in the middle, the normal condition, is the one where we have to go in and check success, fail for both population sizes. So for random, it's pretty standard. They did say in the question that they did a random sample of 300 teens and 400 adults. So that works out. I always say it's better to be descriptive than to not, and then kind of depend on, do they want to give me credit or not? So I always kind of indicate the sample size for each group. So I did 300 teens, 400 adults. Now, again, the order doesn't necessarily matter when you're checking conditions. I went ahead and checked normal next, but you could absolutely do 10% next if that is something that you remember before you remember the normal condition. Now, for normal, when we're doing 2 populations, the first thing we kind of have to check is the successes for my first group. So this is really finding N1 times P1 hat. And sometimes they give you the number. So sometimes within the question, they will say, oh, we have 100 of the 400 people are a success. That would be fine, where I could just say 100 is bigger than 10. In this case, they said that 92% of teens use social media. So because of that, I had to actually multiply it out. That gave me 276. I did 1 minus 0.92, which is 0.08. That gave me 24. And so both conditions are bigger than 10. So we are okay on the front of looking at the teen sample size. Now, what you have to be careful of when you jump to 2 samples is you cannot use the same proportion when it comes to a confidence interval. I now have to look at the sample size of adults, which was 400, and I have to multiply it by the probability of success for that adult group. So this calculation is actually N2, lowercase 2, N2 times P2 hat, and that is what's giving me this 300. So I have 300, which is bigger than 10, and then I do 0.25, which is bigger than 10, and so I get my sampling distribution is approximately normal.
Can we still say the sample mean?
Yes. Now, this is the only, so when we were doing this in Unit 5 and we were doing conditions for sampling distributions, we kind of checked a condition, found a value, or checked a condition, said this statement. This is the only thing that I still do because it's the only piece of information that College Board still requires for these types of FRQs. They don't require that you calculate mean. They don't require that you calculate standard deviation or standard error. They are completely fine within calculations of just getting the interval. So that is why you don't see me calculate standard deviation or mean within the conditions anymore. Now, the last one is just a 10% condition. You do want to make sure you say something like it's safe to assume that it's true. And this is truthfully the 7th time we've kind of run through these conditions in different settings, and they're still the same. So if anything, you should know how to check random and how to check independent, because those two have not changed. The only one that has changed from question to question has been the normal condition, because that's kind of dependent on what information you have and what type of data you're collecting. So going in and making sure that you know those two at least can give you some partial credit, because it does not change from question to question. It is literally the same condition every single time. So both of my sample size seem reasonable enough. There is definitely more than 3,000 U.S. teens and 4,000 U.S. adults. Seems fine. Now that I have checked all of my conditions, Precious, close your computer. Oh my goodness gracious. Now that I've checked all of my conditions, I need to go in and I need to name the test. So the first thing I'm going to do is name what I'm doing. This is a 2-sample Z interval, and this is what I meant when I said we're going to shorthand this a little bit. I will often, instead of saying for a difference in proportions, will just write how I am subtracting the values. You get to decide, as long as the question does not tell you to do a specific direction, so like teens minus adults or adults minus teens, you get to pick what order you want to write things in. So I'm going to take the formula that we just wrote in the previous page, the P1 hat minus P2 hat, and I'm going to fill in the values that I know. So we know that P1 hat is 0.92. We know that P2 hat is 0.75. So that takes care of the point estimate part. We do plus minus. Z star for a 95% confidence interval is always 1.96. And then I'm going to fill in, this is technically the standard error, only because it is being calculated based on a sample and not on a population value. So if you get questions that ask you, what is the standard error? It is just the square root part of this formula. Now, again, most likely you're probably going to jump to your calculator versus calculating this by hand. But if all else fails and you blank and your calculator is giving you an error and you can't figure out what's going on, you still have the formula to fall back on. So I went ahead, plugged this into my calculator, and I got my interval of 0.1176 to 0.2224. Before I jump to the conclusion, because the conclusion is the same as it has been, I want to talk calculator. So if you were doing this in your calculator, you don't have to know the formula. Yes, it's good to know the formula, but you don't have to know it. I can go and it will give me the interval that I need as long as I know the number of successes, the number of failure for both group, and the sample size for both group. So I'm going to open up my calculator really quickly. I am going to go to stat tests. Now for the 1 proportion Z interval, that was letter A. We are going to letter B. So underneath A, you should see something that says 2 prop Z int. You want to hit enter, and then it's going to ask you similar questions to the 1 prop Z int. It's X is number of successes, N is sample size. So for our group, you have to use the calculated values that we did in success fail. There was 276 out of 300 in the teens group who use social media. There were 300 out of 400 in the adults group that use social media. And then you just enter in the confidence level that the question asks for. So this one was 0.95, so I'm not going to change it. And then you hit calculate. Now, because this is replacing the formula, you do have to write the name. You do have to have the name there no matter what. But I suggest that you write everything down that comes from the screen. Technically, you don't need the sample sizes, but usually if I just say write everything down, you're better at that than saying like, oh, well, you can skip this, but you need to have this. Minimum, you need the interval, of course, and the p-hats. So those have to be there, but I usually say just write everything that you have down, and that's how we kind of work. But our interval matches. We have 0.1176 to 0.2224. It's perfect. So now I'm going to go in and I'm going to conclude. This is the same conclusion that we have been doing this whole unit for a confidence interval. Everything that I have highlighted in pink or written in pink is what I would change question to question. Otherwise, the stem kind of stays the same. We are blank percent confident, so 95, that the interval from lower to upper, so 0.1176 to 0.2224, captures the true, and that piece that I highlighted at the very end is what I rewrote here. The true difference between the proportion of all U.S. teens and adults who use social media. The one thing that I am going to kind of harp on, I know we are trying to shorthand everything and we're trying to write as little as we possibly can. However, you cannot skip out on the fact that this is a difference being calculated. If I wrote my sentence as it captures the true proportion of all U.S. teens and adults who use social media, that is kind of saying that you're combining them together in a way. But we need to indicate that we did not combine them, we subtracted them from each other. So if they say difference, don't skip that word. Make sure that you have it in your conclusion somewhere, because you are calculating a difference interval. That is the whole process of what we are doing. But this is the same sentence we used for one sample. It just has that added word in. But the process, basically the same. Communicate, conditions, calculate, conclude. Okay, let's jump to the hypothesis test. I'm going to sound like a broken record. It's basically the same thing. You are still doing the same kind of conditions and checks that you would normally do for a one sample. All that's on the bottom of that page we were just on is the steps for the calculator. So jumping into the significance test, the null, because you have to write the null out, is always that your two groups are equal to each other. So P1 is equal to P2. The alternative is going to be whatever you think is happening. So sometimes you think it's less, sometimes you think it's greater, sometimes you're just interested in, is it different? And so that is going to come from the question. So one other way that they will sometimes write these hypotheses on your test is they will do P1 minus P2 is equal to 0, or P1 minus P2 something less than, greater than, not equal to 0. Now, the only reason it gets written this way sometimes is because when it's written this way, we can kind of take from it that our P naught should be 0. So the null is technically being represented by the value 0. So anytime I eventually go on to kind of relate my confidence interval to a significance test, the value I'm looking for is 0. It will not change. If you are doing a difference, a two sample, it is always going to be 0. Do not put anything else. I honestly, when I teach this, I recommend that you write it like on the left-hand side, simply because it's easier for you to pick the right inequality that way versus trying to decide should the difference be positive or should the difference be negative. Write it like it is on the left-hand side if you are given the option to. Okay.
Is that like, wait, articulate that. I think I lost the question.
What do you mean?
Like, do you mean like when you know when we do the it's like between left center right?
Mhm.
Are you saying to always do it on the to the left? Or?
That's not going to have anything to do with what we're doing. I'm just saying you write your null with P1 on the left-hand side, P2 on the right-hand side of the equal sign, not like on the right-hand side. Okay, conditions. This one does. So remember I talked about how whenever you are doing a hypothesis test, it's kind of like you're being really petty. And you're like, okay, I'm going to believe what you're saying. I'm going to take what you're telling me as truth. And I'm going to do all this work. And I'm going to find this calculation. And I'm going to see how likely it is for me to get my sample if what you're saying is true. So it's kind of like you're using what they're saying against them. And that's always kind of how we approach a hypothesis test. So if the null is true, so if HO P1 is equal to P2, that indicates that there is no difference between the two populations. They are the same. P1 is equivalent to P2. So what we do in the case of P1 minus or P1 equals P2 is we use something called P pooled, and I'll come back up to the conditions in just a second. What we do is we are going to take the total number of successes, so x1 plus x2, and n1 plus n2, and we are going to get this combined proportion. And so what this is going to do is this is saying, well, if these two populations are no different from each other, if they are equal, then I should be able to combine them together with what you're telling me. So if you're telling me they're equal to each other, and I believe it to be true, they should be one big population. So this calculation, this PC hat, is not used for anything else other than a two-sample z-test. So we are going to go in and we are going to calculate a couple of things based on that. Random and independent do not change, but when we come in to check large counts, we have to do it, remember, again, with the assumption that the null is true, we have to do it based on this combined proportion. So we check all four things using PC hat. And before you kind of freak out and are wondering like why, how am I going to remember that? They do give you this formula on the AP exam. It's within that whole section of proportions information. It's just the only thing that you have to remember specifically is that this is used for the two-sample z-test. You don't do it for the interval. You don't do it for one sample. It's only the two-sample z-test. So that's really the only difference. Now, for the calculation of the z-score, it's always value minus mean over standard deviation. So when I go in to calculate my z-score, I am still working under the assumption that the difference is what I'm trying to find. So when I go in to find the z-score, I'm going to do P1 hat minus P2 hat. Technically, you are subtracting 0, which is your P naught. You don't have to write that. It's not necessary, but I'm going to write it because I'm going to show that I did subtract the mean over the standard error. So I'm going to go in and I'm going to use the P pooled value, the PC, and technically this is going to, again, work under the assumption that the null is true. So 1 over N1, 1 over N2. I know that this one looks slightly different than what we've been doing, but just to kind of show you, this is still, this bottom part is still doing the same formula. It's just avoiding you having to write PC and 1 minus PC 2 times, because they are just distributing to both of them. So don't think that you're doing like an entirely new formula. You don't even have to write down what's in black. It is still the same thing. It is still P1, 1 minus P1, P2, 1 minus P2. It's just working under the assumption the null is true. So we're going in with that PC value, and that's what we're using to calculate our z-score. Now for the actual p-value, and remember, test statistic is your z-score value. To get your p-value, you are going to use normal CDF, and that is going to tie directly to your HA. So do you think it's less than? Do you think it's greater than? Do you think it's different? That is where you decide lower upper of the appropriate test. And then the last thing we do is we decide what we're going to do with the null. So if the p-value is less than alpha, we reject. If the p-value is greater than alpha, we fail to reject. So the sentence that we normally write for a hypothesis test is going to be exactly the same. Since our p-value of blank is less or greater than blank, we reject or fail to reject the null. It's exactly the same thing. The only change is you have 2 samples. So let's do a significance test. This one you will want to write small, because this one for sure you don't have enough room for my big writers. I did still divvy this up into 4 sections. That again is completely optional. You don't necessarily have to do that, but I did, and I'll make it look a little bit clearer just so you can see it a little bit better. My 4 sections that I have. Yes.
Sorry. I just need a reminder. Is the alpha is the way you subtract the confidence interval?
So alpha is usually given to you, but with the confidence interval that it's associated with, it should total up to 100%. So like a 5% alpha works with a 95% confidence interval. So they kind of go together. Okay, is there a significant difference in the smoking habits of the younger and older generation? In a random sample of 600 young adults, it was found 180 of them smoked. In a separate random sample of 500 older adults, it was found 185 of them smoked. So kind of going through my chain of thoughts. I have 2 samples. Again, it's not something you have to write, but sometimes it's helpful. I have 2 samples. I can see that they're asking them if they had smoked in the past week. So that is a categorical question. Categorical is always going to be a proportion. Ella and Sam, do I have to separate the 2 of you? You have been talking this entire time. Sam's notes. What does Sam's notes look like? Okay. If I hear you talk one more time, I'm going to separate you for the whole class period. Ooh. Proportions, Z. And so when I read the question, I'm going in to see, am I doing a confidence interval? Am I doing a significance test? So if you see the words, is there convincing evidence, or is there a significant difference? Is there significant evidence? Even going as far as to say this question goes on to tell you, conduct a significance test, you are doing a significance hypothesis test. So we are going to have to write a null and alternative hypothesis. Now, again, if you don't see the words confidence interval and it doesn't talk about a range of values or anything related to that, you're probably doing a hypothesis test. Confidence intervals, they tend to be very, very straightforward with what they want you to do. So kind of take that as one of your first deciding things, because that's going to be the hardest part. I can tell you from what I hear year to year is I know how to do all of the tests when you tell me what tests to do. I just don't know how to decide myself when I have to pick. So with this question, we are going to use a 5% alpha level, and we're going to determine if there is evidence to suggest that, and this is where our context kind of comes in, the proportion of smokers differs between young adults and old adults. And the big thing that I'm interested in is differs. They don't necessarily care that one proportion is bigger or one proportion is smaller than the other. They just kind of want to go in, and they want to, I have to go back really quick. Sorry, my highlightings are going to go away. Okay, maybe it'll go away. No, it's not. 1 second. I have to write it. How sad. For my proportion, so P1, I'm going to say is the proportion of young adults who smoke. And for P2, I'm going to say the proportion of older adults who smoke. Now, you do have to write two hypotheses. In these cases, it's always going to be the same null. If you have two sample, it's going to be P1 is equal to P2 every single time. So I'm going to come in and I'm going to say my null is P1 is equal to P2. My alternative is going to be P1 is not equal to P2. Now, the only reason why I'm picking not equal to is because they want to know how it differs. If they said they thought that young adults was higher or older adults was higher, then I would change my inequality direction, but they just want to know, is it different? So my alpha level is 0.05. Now, I'm going to go in and I'm going to check my conditions. So the first condition is random. So I have a random sample of 600 young adults and 500 older or old adults, whatever you want to phrase it as. I will say I have not graded. I've graded AP exams like the last 3 or 4 years. I've never graded a 2 sample Z interval. They've happened. I've just never had it assigned to me. But I've heard one of the biggest mistakes is how students check the normal condition. And that is, again, because they forget that they have to use that p-pooled value. So with the p-pool value, we have to take the total number of successes over the total sample size. So before I check normal, I'm going to calculate what that value is. So that value happens to be 0.3318. So I take the total number from the young adult group and the older adult group, and I divide it by the two sample sizes, so 600 and 500. Now, this, again, is only because it's functioning under the assumption the null is true. So assuming that what they are saying is fact. So I go in, and I have two sample sizes. I have 600 and I have 500. I have to calculate success and fail for both of them, and I have to make sure that they're bigger than 10. So again, we're going to do success fail for 600, and then we are going to do success fail for 500. I will tell you this, you will not, I'm not going to say like 100% guaranteed it's never going to happen. They rarely ever have you do 2 inference tests on the AP exam and they're both 2 sample. So if it does happen to be they want you to do a 2 sample twice, one of them is usually assume all conditions have been met. So they'll do something where they tell you that all of the conditions are fine and you don't have to check them twice. I know you're writing a lot. And for the most part, that's because you're doing very, very little math, just very little, because you will be using your calculator, probably guaranteed, and they're just taking those values that you have and you're applying them to the situation. So I did success fail for the young adults, I did success fail for the older adults, and everything ended up being bigger than 10. So I can say sampling distribution is approximately normal. That condition is met. This is one where if you star or highlight things that you need to kind of be careful about, this is one where I would make sure you kind of have a note that you have to use PC hat, just because it's the one completely different thing compared to everything else that we do. So I have my normal condition, and then the last one is your independence. All of them are safe to assume. We say works out fine, not bad at all. And I will say, as I have graded some of these in the past, a lot of people do random and independent first because they know that those two apply in every situation. And then they kind of get down to normal, and that's when they kind of play around with okay, what data do I have? And how can I verify that this distribution is normal? Usually with confidence intervals, they make the right decision because they only have one option. You only get sample data, so that's what you use to plug in. But significance tests is where people tend to go wrong because you have to use the population claim for one sample, and you have to use the P combined for two sample. So that's where a lot of mistakes end up getting made. Okay, conditions, done. The next piece of information. So I, again, am going to walk you through the steps by hand because, again, you may see multiple choice questions. I can probably guarantee on my test you will see multiple choice questions that ask you which of these correctly calculates the test statistic. And it'll be a bunch of different formulas that look almost exactly the same, but the numbers will all be in different places. So you have to know what the formulas look like. And they are starting to do that more and more on the AP exam because they know more people are just using the calculator to do all of this. So the first thing we're going to do, name the test, two sample z-test. And you, my calculator users, have to do this. If you do not do this part and you go straight to the calculator and you say z is this, p-value is this, and you don't do anything else, they will give you no credit for it. Part of the whole process is knowing what tests to do. Now, if you wrote that at the very top, when you were deciding what to do for the test, they're going to give you credit for it. It just has to be on your paper. So now I'm going to go in, I'm going to calculate my z-score. So z-score, and again, you don't have to write 0. I wrote 0 just to show you that I did subtract the null proportion from this problem, but I have my z-score formula that I plugged in my P1 hat, my P2 hat, and my P pooled, P combined, whatever direction they're leaning in this year, value. So I take all of that, plug it into the formula, and I get my z-score of negative 2.4551. Now, this value is what you are going to take to normal CDF. Before you get there and before you start plugging in, one thing you want to pay attention to is it positive, is it negative? Because that's going to kind of tell you where it falls on the distribution. But this particular question is a difference question. So that means it is shading below and it's shading above. So technically, I have a negative z and I have a positive z. And so when you're doing a not equal to, you have to take into consideration both sides of the distribution. So when I go in to find the p-value, I'm going to go in with the lower bound in mind simply because I have a negative z-score. So I did negative infinity to negative 2.4551, and I got a p-value of 0.007. And before you go in and box that answer, just remember this is only the lower half. So this area in the bottom is 0.007, but I also have to remember that this is a two-tailed test, and if it is two-tailed, that same area is also in the top. So when I go in and I actually calculate the true p-value that I should be interpreting, I have to remember to either add it to itself or I just go in and multiply it by 2. I have gotten the question, when I use the calculator to do this, do I need to take the p-value and double it as well? You do not. The calculator itself, in the calculator function for the test, is going to do that for you. So they are going to give you the already doubled value. They are not going to make you do that yourself. So before I move on, because again, I want to show you kind of calculator steps as we go, what the calculator is replacing. So all you would have to write instead of all of this is you will have to name it. So you'll have to say 2 sample z-test for whatever subtraction you're doing. You are going to have to state the z-score, and you are going to have to state the p-value. Now, additionally, I will always recommend to write down all of the p-hats, just in case something went wrong and you plugged in the wrong value. They can at least see that, like, oh, their p1 hat is off, which is why this whole problem is off, versus they have no idea what you did and they have no idea where you went wrong. So in our calculator, I'm going to go to, let's open it this way. I'm going to go to stat. I'm going to go over to tests. I'm going to go down to option number 6, which is a 2-prop z-test. They are very nicely named. And I'm going to go to my number of successes. Be very careful, because a lot of people make the mistake of using what we did for the normal condition, and they want to type in the 199.08. For one, you can't type in a decimal, but 2, that is not the number of successes in our sample. We had 180 in our X1, so 180 out of a sample size of 600, and then we had 185 out of 500, and then we want it to be a not equal to, and so then we hit calculate, and you should see a z-score and a p-value that are pretty close, if not exactly what we got. And notice that their p-value is already 0.014, so they have already done the doubling for you. The only time you double it is if you are calculating it yourself. So this calculator steps takes the place of all of the work that we just did. So you can do this. It's just make sure that you're still somewhat familiar with the formula. So now that I know my p-value is low. What do I do if my p-value is low? You reject the hoe. So we are going to reject the null hypothesis. Since the p-value of 0.014 is less than alpha, we reject the null. There is convincing evidence, and here is where I kind of go in and copy from the question. The proportion of smokers differs between young and older adults. One of the other blanks that I do typically have is the less part, so I'm going to change the color of that. Since the p-value is less. If it was greater, we would fail to reject, and you would not have convincing evidence. So, like I said, these conclusion sentences are the same conclusion sentences you will be writing from the very beginning. You will write them in Unit 7. We will even take it all the way to Unit 8 for significance tests. It is the same sentence every single time at the end of your FRQ. The only difference is it a confidence interval or is it a significance test? So the next 2 parts, the A and the B, they kind of incorporate 6.3. So I'm going to kind of do a brief like Cliff Notes version of what the 2 main ideas of that lesson were. One of them was types of error, and one of them was how do I relate to a confidence interval to a significance test. So for types of error, there is always a potential that all of the work we did is wrong. Like we had a bad sample, our sample led us to a wrong conclusion. It's just naturally what could happen. So there are 2 types of error that you can have. You can have type 1 and you can have type 2. They are not very fun names, but they are different. Now, all that this is tied to is what decision did you make? So if you decided to reject HO, there is always a potential you did so incorrectly, meaning the test led you the wrong way. Not that your test is wrong, not that you did the work wrong, it's just that it's not what you said. So if you rejected HO, you potentially made a type 1 error. If you, in your decision, decided to fail to reject HO, that means you potentially made a type 2 error. And I always remember this by saying fail to reject. So fail to reject is type 2 error. Now, based on what we did, in our conclusion, we rejected. So I would say something like, because we rejected HO, we potentially made a type 1 error. And all that means is we rejected the null incorrectly. So we just made the wrong decision in the end. But there's nothing you can do to prevent error. It's just a possibility of what can happen. And usually, for the most part, you're just identifying what type of error it could have been. It's always tied to your decision making. Now, the other thing that was kind of covered in that was, how do I relate a confidence interval to a significance test? So I went ahead and I calculated a 95% confidence interval for this situation, and I used the calculator, and so I got negative 1.126 to negative 0.014. And the other thing that I want you to kind of note is that we said if I'm doing a 2 sample, the null proportion is always 0. So if you're trying to use a confidence interval to decide if you're going to reject or fail to reject, or if you have convincing evidence or not, all you're doing is asking yourself, is the number, even if this is a 1 sample, it's true for that, is this number inside this interval? So does it actually fit within the interval? If it does, you cannot have evidence against the null. It's a possibility for what it could be. But if it's not, so in this case, 0 is not between 2 negative numbers, we have enough evidence to reject the null. So because the interval does not contain 0, we reject HO, or the null. This matches our decision from the significance test. They should not contradict each other. They should always have the same reject or fail to reject decision from the test to the interval using the P0. So that's kind of a very short explanation of what that video covers, but that's kind of the 2 main ideas, is types of error and how do confidence intervals and significance tests relate. Okay, you guys, you have a math lab to work on. You have 2 math labs to work on, technically. Our test date is the 19th. It is a Thursday, yes.